So when I have just a list of data, the average is the sum divided by the total, right? That's the old average we've known forever. When I have this set up here, the average would be x times p of x. You sum those up, right? So that when they give it to me like this, when they give it to me in a binomial situation, and what are they going to have to give me for a binomial? They're going to have to give me a probability of success. I can figure out the failure then, 1 minus that. They have to tell me how many times, like I'm going to flip it 14 times. They have to tell me n, p, and q, right? So I should have formulas based on that presentation, right? So they just give me a list of data. I've got my basic formula. Add them up, divide by how many they are. That's how you get the average. And then our good old sum of x minus the mean squared divided by n minus 1. Ooh, that was for the standard deviation, right? For this situation, with sum of x p of x and sum of x squared p of x, and you throw in the formula, because it's easier to do that formula when it's in this way. And for this way, these are the easier formula to use. Now I could take the probability formula and make a table like this, and then use sum of x p of x, but why do all that crap when it's this easy if I have a binomial situation? That's what I can use, right? Just like this. I want you to really think about it. I could take almost any situation and put it into this format or a list of data and then do it that way. But why do that if I have formulas for the way it's given to me? Okay, maybe. So the average here, we already know. The average here was 14 times 0.5 is 7. That's why it was not surprising at all that I got that. Even if I wouldn't have gotten 10, I would have still expected a large number. But would I be guaranteed that? Is it impossible that I would have put a 0 here? Could there? Yeah. Is it impossible? No. You certainly could have all flipped it and nobody got 7 hits. What's the connection then? When should it be? I tell you the expected value is 7. So probability only makes sense when you do something a lot. And that's a mistake people make. Probability only makes sense over the long term. So when I analyze the situation, I'm like, should I invest money in here? And I do a little xp of x table to get my expected value. Do you remember this? So if it was negative, it's bad. If it's positive, it's good. That only means if I do that kind of thing many, many times, I expect to make that much money on average. Right? So it's got to be over the long term. So I can flip a coin and get nothing but heads 1,000 straight times. Is that impossible with a fair coin? It's not impossible, but what am I going to start to think if I get 1,000 heads in a row? I'm going to think something's wrong. That's evidence that something's wrong. Is it guarantee something's wrong? No, it's not impossible. People seem to think that a coin has memory. You flip it, you get a head. You flip it, you get a head. You're like, oh, it's going to be tails now. No, because every single time you do it, there's a 50% chance. Cool. Okay, maybe. All right, so what's the standard deviation for this situation then? What's n? 14. P is 0.5, and of course Q is 0.5. 50% chance of heads, 50% chance of tails.
What's Q again?
Q is just probably a failure. So in this case, success would be a head, because that's what we're counting. Failure would be the opposite, a tail. In this case, yeah. There's only 2 possibilities here. Both of them we're assuming to be equally likely. Yeah?
Where did you get the 0.5 in the middle?
So what is P? Probability of what? In this case, probability of head, right? So what is the probability of getting a head? 50%. 0.5. Because what's Q? Not getting ahead. So if they're probably getting ahead is 50%, probably not getting ahead must be 50%. So what's always true about P plus Q? Has to be 1. I love it. So what do you guys get for this? Square root of 3.5 should be 1.8. What is it? 1.87, really? Sweet. 1.87 what? I mean, keep going. How far do you have to go in standard deviation? At least 3 places, right? 871. 871? Sweet. So look at this real quick. Now that we got all that kind of figured out, I want to make the connection between what we just did and this paper here. Oh, that's right. Wait, fuck. So look at the very bottom of this paper. For some reason I decided to do this first. That's just bad for me. So we figured out the mean, we figured out the standard deviation. And of course, before you square root that, that would be the what? If you don't square root it, what do you have? Variance. I love it. Right? So that's that middle thing I'm asking for, sigma squared. That's variance. So can you figure out now what the minimum expected number of heads and the maximum number of expected heads would be? Do that. What would that be?
You want me to tell you or I can describe it?
Well, right now.